I never notice how streaky it is until the lights are out, so deal with it. So you know what we have for dinner tonight? Spaghetti tacos. It's a regular occurrence in our house these days. What are you gonna do? Let's go make some videos. That's also from our iCarly, right? Okay, welcome back everybody. Welcome back. This is the third installment for the analysis phase of unit hydrographs, where we are learning how to create unit hydrographs given the input of rainfall hyetograph shown in this column and as the bar chart on the figure, and runoff shown in this column and as the hydrograph. This is for a particular example problem that we'll be going through, which is also in your handout, and the problem statement states that this rainstorm falls over a 182 square kilometer watershed, produces this hydrograph, and we are going to assume a base flow of 15 cubic meters per second, and from this input and the base flow, we're going to determine a unit hydrograph. So step one again is to figure out the base flow. That's given to us, so we can just start filling that in. Okay, once our base flow is put in, we're going to move to the next step, which is to find the volume of the direct runoff. So we need the direct runoff for all of these time ordinates, all 13 hours given. So we're going to determine that by taking the runoff minus my base flow is going to give us our direct runoff. If you remember from the previous video, when we had our hydrograph and our base flow, everything above that base flow is our direct runoff. So our direct runoff is going to be the runoff observed and given to us minus the base flow. And so in this case, I'm just going to take my runoff, subtract 15 for all of the rows. So the first one is 0. The second one is 163. And then I'm going to speed up time. What do you know? Instantaneously filling out that column. So now we have our direct runoff hydrograph, direct runoff, and we need to sum that up. So we are going to sum all of my direct runoff. So you can quickly see that doing this type of analysis in some type of spreadsheet is going to be really helpful. And if you do that, you should get 2,529 cubic meters per second. So that's the total flow that goes through the outlet of the watershed. We're looking for a volume. We did this back in the very beginning of the quarter when we looked at conservation of mass. So my volume is going to be that 2,529 cubic meters per second. I'm going to convert this to hours. That's the time that we have. And you will get 9104400 meters cubed. I'm going to do a little manipulation here and write this as 9.1044 kilometers squared times meters. Okay, so I've converted just 2 of the meters to kilometers. And why did I do that? It's because I have my area in square kilometers. So my depth now, I'm going to take that total flow and divide, why did I write that? Times meters. Divide that by 182 kilometers squared. That was given in the problem statement. And I get 0.050025 meters, which is 5.0 centimeters. Okay, let's step back and think about what this 5 centimeters means. This 5 centimeter means that for the given watershed, here's my watershed with an area of 182 square kilometers. If this rainstorm fell on that watershed and then we allowed all of the storage and infiltration to occur, we would be left with the entire watershed covered with 5 centimeters of rain. Okay, of course that's not what happens. This is not a pool or a bathtub. Instead, it's draining out of whatever outlet it has and moving downstream. But that's what this 5 centimeter means. Okay, it means it would be covering the excess rainfall would cover this entire watershed with 5 centimeters of rain. Okay, so that's step number 2. Step number 3 is to divide this direct runoff by the depth. And why are we doing that? We just did this calculation to find that this storm translates to 5 centimeters of water over the watershed. We're looking for a unit hydrograph. And remember, a unit hydrograph represents 1 unit. So in this case, 1 centimeter of water falling, covering our watershed. Okay. So we need to convert this. We're going to divide everything by 5. When we divide everything by 5, it will represent 1 centimeter of water over this 182 square kilometers. Okay, so again, the magic of math here, I'm going to take and divide all of these direct runoffs. Oh, my magic of this whiteboard and this recording, I'm going to divide each of these by 5. So 0 divided by 5 is 0. And then 163 divided by 5 is 32.6. And then, okay, so here's my unit hydrograph. That's it, we're done. Let's just check that this worked. So I'm going to check the volume for my unit hydrograph. And what I want it to be is 1.0 centimeters. So I am going to sum that column that I just created. And if you do that, you get 505.8 cubic meters per second. Convert that to a volume, doing the same process we did up here. I'm going to do 505.8 cubic meters per second. And multiply that by our time and get 1820880 meters cubed, which is 1.821 kilometers squared per meter, which is, do the math, 1 centimeter. Okay. All right, so we now have our unit hydrograph. We're not quite done yet. We know that if we get 1 centimeter of rain, we can get this unit hydrograph out, but only for a particular duration of rain, and that's the last step. So one last video to go here. Step 4 is determining the time base for the unit hydrograph.